Yes. So, good evening, everyone. Am I audible?
Yes, good
Good
evening,
evening,
sir.
everyone. Yes. So, dear participants, we welcome you all for the third day of this International Research Methodology Workshop. Happy to see you all. Today we will be having the same resource portion, and as like yesterday, we will be having the same hands-on session for today also. Requesting all to cooperate, and if you have any doubt, as like yesterday, the resource person will give you enough time to clarify your doubts. And definitely, this session also will be a useful one. And without taking much time, let me directly hand over the session to Shobna ma'am. Our one kind announcement, we have one more event which was on July 26th, like how to write a proposal writing for the funded projects. So if you're interested to join there, you are most welcome to join in that particular workshop. Thank you so much. Over to you, ma'am.
Yeah, thank you, sir. Good evening, everyone, once again. So, welcome you all for the third day of the International Workshop on Research Methodology. So, we will wait for another 5 minutes more. Let few more participants join. By the time, if you are having any queries related to the last 2 days session, you may put in the chat box accordingly. I would like to take any questions related the first 2 days uh, for another 5 minutes. If you have anything, you can put in the chat box. Okay, fine. Then we shall proceed with the today's topic. So today we are going to discuss on hypothesis testing. This, especially in that application for small and large sample, and preferably we are today going with MS Excel. So this is your second part or second branch of statistics. We can see the first branch we have already discussed, that is descriptive statistics, and the second branch is inferential. In that, we have a sub branch of hypothesis testing. So, when I say inferential statistics, it's where the statistician use data from a sample, that is a subset of population, what we say sample, to make statement about a population. So in that, we have two main areas of inferential statistics. One is estimation and one is hypothesis testing. So generally when we go for any data analysis in the for a paper and to make it more good and a very high level in that, we would try adding hypothesis testing to make our paper more reliable. So let's see today the procedure of that. So today we are going to focus only on two tests in detail. So before going that, let us see a small definition for your understanding or a recall of population and sample. So any specific collection of object of your interest, any specific collection is population, and any subset of the population or sub collection of the population, we say it as sample. So when I say hypothesis testing, it is just testing a statement. So when I introduced about statistics, that time I gave few examples for your understanding. So today we will see which type of test is used when, how and why to give conclusion to the claim made. For example, you might be interested in knowing if a new technology of teaching is effective in children to perform better. So how are you going to give a conclusion for this claim? You will see the students' performance by some activity before implementing the new technology, and then after implementing the new technology you will again see the students' performance, and you will apply the suitable test and on that. Of course, by observing also you can say, for example, before implementing the technique, the students' marks are very less, the score is less. After implementing the technology, the scores are better. But just by observation, a paper would not rely. We have to go for an hypothesis testing. Why? We are not doing for the whole population. If you are doing for the whole population and by observation you are able to say well and fine, but which is not feasible. We can do only, we can work only that on a sample. Hence, to generalize for the population, we have to go for hypothesis testing. So whatever test you go for, whichever test you are going to go for, TZ, Z test, chi-square, ANOVA, and few, these are few parametric tests which can be performed in Excel, and few more tests which can be done in SPSS and other software. Whatever test you are going to perform, the standard procedure of testing of hypothesis is as follows. So whichever test you are going to apply, that is the next slide. But for that, general, these are the following steps. So it is advisable that you could write it down simultaneously so that when we will be solving, you are having in front of you to refer that. So step one is stating the hypothesis. So we have two types of hypothesis: null hypothesis and alternative hypothesis. So generally, or standard way of defining the null hypothesis is assuming it as equal, assuming the parameter of two samples or test assuming the parameter to be equal to the hypothetical mean or variance. It's like you say in statement wise, there is no significant difference between the variable which you're going to test. So when I say there is no significant difference, means there is they both are equal. That is what notation wise goes. But when I say the alternative will be alternative of equal to, which is not equal to, hence we say there is significant difference between the variables which we are going to test. So the main first step you start with by stating the hypothesis. So uh, you should practice enough problems such a way that you don't make mistake in framing the hypothesis, and that should be very much clear, as when you make wrong claim in the beginning, of course your conclusion will also go wrong. So your claim should be very much clear. So the standard way you have to remember is there is no significant difference and means equal, and alternative there is significant difference. Next step is to decide the appropriate statistical test. When we go manually, there is one more step in between these two, that is deciding the level of significance, which we had seen yesterday while performing the regression analysis. One of the option confidence interval by default was 95%. So 100 minus of that is level of significance. So as I said, generally we have three level of significance: 1%, 5%, 10%. Now, what is this level of significance? It is also called as allowable error. Allowable error. So when I'm saying 5%, that the confidence interval is 90, that is 95%. 5% chance the error is allowed. Hence, in standard, we take 5% because 1% when I take it's too risky, and when we say 10%, then it is too far. Hence, we take a standard value in between of both, that is 5%. Okay, and after that, we decide the appropriate statistical test. What is this PT and NPT? Under that, we have two categories of test. We had already seen uh, when we discussed about the types of data, quantitative and qualitative. So that has an important role here to decide the appropriate statistical test. So PT is parametric test, NPT is non-parametric test. So we will understand in the further slides how to decide that in detail. So your step 2 is to decide appropriate statistical test. Once you are decided which test to be performed, then you are going to perform it with any suitable tools. Today we are going to prefer Excel. Maybe in the further last lecture I will show all this thing in general in SPSS also short, just part way so that you can practice that too. Step 4, decision criteria. We had seen this also yesterday for regression to understand the model significance. So that is going to be a standard decision criteria for any hypothesis testing too. If p-value is less than 0.05, that is actually alpha what we are going to take. So we take generally 5%, right? So it's taken as p-value less than 0.05. We reject H naught at alpha percent LOS. Okay. Finally, after comparing our p-value with the standard alpha value, we give the conclusion and we interpret a result accordingly. So hope this step is very very clear, and I suggest that you may kindly note down this step in short so that you are able to do or perform along with me when I'll be performing in Excel. So you remember the steps what has to be done in a particular order. Okay. Alpha is 5%. Level of significance, LOS level of significance. Just what I said, allowable allowable error. So in general, we take 5%. Okay. LOS level of significance. So now comes to the main step, which our step 2, how to identify step 2. Statistical test to select. So these three questions should be answerable. Which test should be selected? Why we are selecting that test? Or when we have to select that test? So here comes the tough decision of deciding parametric या non-parametric. So if you make mistake in identifying this, whether parametric or non-parametric, then further again everything will go wrong. So at the beginning, you should be able to identify clearly whether parametric or non-parametric. So it will depend upon the type of data I already mentioned. If your data is qualitative, if your data is qualitative, you don't have any other option, nothing more to see here and that. Simply you will go to the category of non-parametric test. So I'm repeating once again. If your data is qualitative, no need of thinking much. Simply you are going to go under the category of non-parametric test.
Hello, ma'am. I just want to interpret. Sorry. I just want to know that when you mean by qualitative, you are referring to nominal and categorical, right?
Correct, correct.
Okay, thank you.
Yes. Further in that, we will see one by one later ki which tests under that. But the first category of deciding parametric and non-parametric will depend upon the type of data. Now, why non-parametric? Because parameter is not defined. Now, what are the parameters? It is the numerical summarization of an population. Numerical summarization means mean, variance, standard deviation. So when it is nominal or ordinal, we cannot find mean and variance. For example, like gender, if I say male, female, so it is not feasible to compute mean and variance for that data. If it is of ordinal scale, rating from order 1 to 5, which says very dissatisfied to very satisfied, the level of scale. Again, in that, we cannot find mean and variance. So it comes under the category of parameter not defined. Hence, that type of data comes under non-parametric test. But when I say quantitative type of data, then we have to go one step more in that to decide or to check the assumption called as normality of the data to decide further to go for which test. So if my data is normal, then we have to prefer parametric test. If the data is not normal, then we go for non-parametric test. So even if your data is quantitative, but if your data is not normal, you are supposed to go for non-parametric test. Okay. And if it is normal, parametric test, because parameter is defined that we can compute mean and variance. So for non-parametric test, there is no assumption of checking. For parametric test, our data should be normal, that too quantitative. So if this thing is clear, if this chart is very, very clear in your mind, and anytime you start, only this chart you bring in front of you, you will never make mistake in identifying which category to go for. And here once it's clear, then under that which test you have to go, that would be not that difficult. So let's see what are the different way of checking the data to be normal. So there are different way of checking the data to be normal, and few of them is feasible in Excel and rest all are feasible in other software because Excel has little limitation, right? So not all is possible, but at least few. So we will see which all test is possible by Excel. So first one, with the help of skewness, but this is not that much preferred. It is not that reliable, but to some extent we can go for this. If skewness value is between minus 0.5 to 0.5, we can say that the data is approximately normally distributed. Next, by QQ plot. So in last class you had already seen this. In while doing the regression, we were getting this QQ plot. But it was for the regression because it can do after computing the residual only, right? After computing the normal probability plot. So hence, in Excel, we prefer skewness or the further thing. This is QQ plot is preferred in SPSS and other software. Histogram, yes, this is also preferred by Excel. When our histogram will look like a bell shape, approximately at least like a bell shape, we can prefer, we can say that it is normal. And other than all these three, the best one because all the three we say approximately. But the last one is statistically we can say using the significant value, which is the reliable one. By Kolmogorov Smirnov goodness of fit test. So this test, of course, is possible in SPSS and R only, not in Excel. So that will give you statistically significance about whether the data is normal or not, because we give the conclusion using the p value, that is the significant value. So for that we use this as the hypothesis: the data is normal and data is not normal. So let's see in detail about the parametric test. So we define with uh, it goes by based on two parameters, mean and variance. If it is mean, then these are the possible tests: t test, z test, ANOVA. Further with few more constraints under that. And if it is of checking the variation between any two sample, then it's an test called as F test. Okay, so we will see one by one in detail. Today I will be covering in this session t test and z test. ANOVA we will see tomorrow's session. So when we will be performing t test, during that time simultaneously F test will be also covered at one particular step. These are further more in detail based on the samples. If it is one sample, then what are the possible tests? Two or more sample, then under that we may have the category like independent sample, paired sample, then the possible test name. And under non-parametric, again in that format, based on the samples, the commonly used tests are listed. So again, this is an overall summarized chart. So this test is for examining the significant difference between the variables. But if you want to examine the strength of the association, whether the two variables are related or not, what is the strength? So in parametric, it's correlation. Further, if you want to know about the prediction, we go for regression, which we are already done. In that, we have non-parametric also to know the strength of the between two variable. So here the name is Spearman correlation and Kendall, which you can observe in SPSS. To examine statistically, okay, then by the significance value, we go for chi-square test, And basically, chi-square test is called as a distribution free test because it doesn't follows any distribution and there is no parameter involved. Hence, we say it as non-para category under non-parametric test. But this is one of the tests which is there in which we can perform in Excel too with few manual calculation. So to examine the independency or how the data variable is related or associated, we go for chi-square test. So in t-test ANOVA, we say the statement as there is no significant difference, but here we say the statement as there is no association or significant association. So when it comes to difference, it is basically for mean difference. And when I say association, then to check whether the two variables are related or not. So this all theoretical concept is to be known. Hence, I'm first discussing the theory concept whichever is required for today's session so that you are able to understand when we are going to perform in practical. This is the overall summary about t-test and z-test. So many have confusion about t and z. They few know by one rule: small sample and large sample. If it is small sample, we go for t-test, and if it is large sample, we go for z-test. But yes, agreed. But practically, when you see the thing behind it is about the variance. If the variance is known, then it is Z test. Maybe the sample size is big or small. So variance will be known when it is an information of population actually. And when we do manually, we teach the students with Z test by giving the information of variance in the problem. But when it comes under the real life application of statistical analysis, you may just take a few moments to recall. You may not see in any of the paper, or I can't say any, most of the papers will have t-test only. T ANOVA. Not, you may might have not gone off the word as z-test. Because actually z-test is used when variance is known, and variance will be known only if it is of population information is known to us. But of course, unfortunately, we don't get the population information. Hence, we are going for hypothesis testing because we are having the sample. So when variance is not known, we go for t-test even if the sample size is large. This has to be taken care. Okay. And of course, when it is association, it's chi-square. So the only thing is you should know variance is known or variance is not known. That's all. And when it is sample, it is obvious that variance is not known. So this is the quick short introduction of what we are going to do in today's session, the theoretical concept to know when, why we have to go to a particular test and which test should be taken when. So 5 minutes to you all. I shall give you 5 minutes. Any doubt you can raise. So meanwhile, if there is any questions in the chat box, I shall cover that also. Ma'am, please define the difference between one sample and two sample. Yes, sure. I will do it that when we will be doing in the exercise. Orally, it is not that much clear to understand. I will show you that while working in an example. When we have to check the impact of variable and the data is non-parametric, then are we examining the strength of association? No. Strength checking examining the strength of association is to know how the variables are related. That is what examining the strength of association.
Good evening, madam. Good evening, madam.
Yes, yes, sir.
Madam, I am Hanumanta from Karnataka, Dharwad.
Yes, sir.
Madam, you was mentioned that the hypothesis test in tools like Excel and SPSS.
Yes.
So, how can we test hypothesis or chi-square test in Excel, madam?
Yeah. So today's session is based on T and Z test.
Yes,
So when
madam.
it will be a chi-square session, I'll be explaining that most probably tomorrow.
Okay, okay. Thank you, madam.
Yes,
Thank
sir.
you so
Yes.
much. Thank you, madam.
I think Bennett sir would have shared you the data set for today's session. You can all be get ready with that. I shall too get ready. Then in 5 minutes we will start with the Excel session.
Thank you, madam. Thank you.
Yes. Ma'am, these are the following ways to check the normality of data.
Ma'am, how can we check the impact of variable on dependent variable when the data is non-parametric?
Ma'am, in Excel it is not feasible. We are focusing the first 4 lectures on Excel only. When it is
Okay,
coming on non-parametric, it is all that non-parametric data is done in Excel. Sorry, SPSS, which we will be covering on the coming days.
okay, ma'am. I just wanted to know about the type of test that will be used.
So this is what I had mentioned in this slide for your reference. It's we say in parametric it is Pearson, and in non-parametric we say it as Spearman or Kendall Tau correlation.
Correlation. Okay,
Yes.
ma'am. Thank you.
Both are
Thank you.
correlation, just the name is Pearson for parametric and Spearman for non-parametric.
Thank you, ma'am.
This is the Excel sheet which I'll be talking about. So we will work today in this Excel sheet. So you all may get ready with this. First, I will explain this data set and we will state few statement to be tested. Then we will see how we decide which test. And then I shall help you out how to perform the test and give the conclusion. So you all can kindly note down these three questions which we'll be discussing today. Of course, this is in sample data. So variance is not known. So we have to go for t-test. If variance is known, which doesn't happen in live data, in that case, it is z-test. For example, the sample size itself is small, and in that particular case, the population size is very small, and you are able to know the variance, so you can go for z-test. But generally, as we said, we get the data, and data is from the sample. So you can note down these three questions to be answered, and then we will take one question to understand how to perform and give the conclusion. So I think we can take now the first question. Hope all is set. So let us first understand this data. We are having the department, the HR department, sales department, and their face is productivity. We have IT department and some mixed department, and they have gone through with few training also, and for each department we can see their productivity score. So the first claim here is HR's average productivity different from the company benchmark? So this benchmark, a hypothetical value, it is called as an hypothetical value which would be considered by the company, hence it is called as company benchmark. By past experience, by previous data, etc., they decide an hypothetical value, say 75 year. So here I got one of the question that how do we decide one sample and two sample? Define that, how do we define the difference between one sample and two sample? Okay, so this question, this will make clear or will give you the answer for that question. So here it says only about the HR. They are saying that is the average HR's productive different from the company's benchmark. So here I will be taking only the information of HR and I will be performing the test and we will get the conclusion accordingly. So this is called as one sample test because here only one sample is considered, that is the HR. And one more thing to be noted, in Excel there is no inbuilt or a tool inbuilt way to get directly from the analysis toolpath to perform one sample t-test. Okay, in Excel from toolpath we cannot perform one sample t-test, and mostly while doing in research work also we generally don't have the statements or claim for going for one sample t-test. Okay, if so, then we have to go manually. So here also if we want to check this conclusion, we have to go it manually with putting the formulas, then substituting the values in that, then we get the cal value, from that we compute the p value, etc., to get the answer. So which is not going to be done in detail here because that is we can see in the SPSS. Let us come to the second question. Is there a significant difference in productivity between sales and training? Now here if you see, the question says whether there is a significant difference in productivity between sales and IT. So here I have to take the information of sales as well as IT. So two independent sample, sales and IT are two independent sample, and this is what an example of two sample test. I hope, madam, your question is answered in this. So, when it is two independent variables category, so here it is sales and IT. Not necessarily only sales and IT. I can check whether there is difference in productivity between HR and sales, HR and IT, sales and mix, like that. Any two category you are going to take which are independent, it comes under two sample and specifically independent T test. So I will perform and show you the for one category sales and IT. Then I will give you few minutes. You can perform and see two more different category like HR and IT. Then you can see HR and sales, just to know the way the step, just to give you confidence that you are able to do how till what step you are able to do alone. So as usual, we have to first structure the data as per the requirement for inputting, and then we go for the analysis part. So let us first take this data in a new sheet. So let us start with the first step, that is defining the hypothesis. So here it is about sales and IT, right? So let us segregate that data in a different sheet. Sales and IT. So you have to make that in a two different column. So this is the sales score, and this is IT score. Rest all column not required, and we can remove it out. So kindly do this first. That is, we have to make the data presented as per our requirement in putting in the input space. Okay, so structuring data is done. Then let us have the step of hypothesis testing. So starting with defining the hypothesis in that H naught. So we start with the statement there is no significant difference in productivity between sales and IT. In productivity between sales and IT. So you can just copy paste that and make the necessary changes for um, alternative hypothesis. There is significant difference in productivity between sales and IT. Okay, so I think defining the hypothesis is clear to you all. There is no significant difference, and there is significant difference is the standard statement to start. And what we have to do, the claim, the question is mentioned in productivity between sales and IT. Now, the appropriate statistical test. So, when you are going to on a proper research way, so of course, we have to check that assumption of normality. It is quantitative data, so you have to check the assumption of normality. So let us, of course, the preferred one is the statistical one, right? But which is not feasible in our Excel. So at least let us see the skewness value. What comes to the skewness value for this two date information? You can use the descriptive statistics where you will get the complete descriptive summary, or for skewness simply you can write only skew and you have to select only the numbers. So that is from A2 till A21. So what was that range mentioned for skewness? It should be between 0 minus 0.5 to 0.5. Yes, so both the values are under this range. So approximately this is normal. So I'm repeating once again. The best one, the reliable one is by checking statistically, which is not feasible in Excel. But to some extent, we can do by skewness or histogram. Histogram has a long procedure. So for simplicity, we go for skewness. Approximately, we can make an checking of normality in this. If that skewness value is between this range, so we say approximately it is normal. So the first one is very much close, but still it is under the range. So we can say both the values are satisfying the assumption of normality. Hence, we go for the t-test. Okay. And coming back to our step. So statistical test, since it is of two sample, that is we have to go for two sample t-test, which is also called as independent t-test, because the sample is independent. Sales and IT are two independent data, so we say it as independent t-test. Yes, I shall show you the formula once again. It is simply equal SQ and you select only the numbers, not the column heading. Here it is given in the parenthesis number 1 comma number 2 dot dot, so you have to select only the numbers. So it is from A2 to A21 and you get the answer. So similarly you can do for IT. So this is the sales skewness value and this is the skewness value for IT score. So I'll wait for 5 minutes. Those who are performing, you can note down all the steps and perform and see. Then I shall perform and show you the main step, and from that we can give the conclusion. Whatever you want to write it down for your understanding, you may do that. So the time was sufficient for you. Let us go for the next step now. Now we can go to the analysis tool pack to perform the t-test. So moving to so procedure remains the same. Data analysis. So mostly I think it's in the last end. Yeah. There are 3 t-tests mentioned here. First one is t-test pair 2 sample for means. So this is not an example of paired. T-test 2 sample assuming equal variance. T-test 2 sample assuming unequal variance. So yes, this is our case, 2 sample. But now in this, which one to select? Assuming equal variance, yeah, unequal variance. So to decide this, we have to first perform the test of variance. And to perform the test of variance, which is the suitable one, anyone would recall when I had explained the chart? Did anyone note it down when which test is suitable when we have to test the variance? It is the F test. It was this, yes, it was in this slide when I explained. So it is F test. Okay. So that is what we have to go stepwise. I will show you that too. Other than that, there is one more way, that is what we say a smart way or a trick to identify uh, which we have to uh, consider or which we have to take. So first I will show you that, and then let us verify it with the F test whether it is matching or not. Okay. So first I will perform and show you both the case t-test with equal variance and t-test assuming unequal variance. So let us select t-test with equal variance. What you have to put, just input all that question is asked. Variable 1 range, that is the sales score. Variable 2 range, that is the IT score. Then hypothesized mean difference, by default it will be 0. Label, by default alpha will be 5%. Yes, output range, give one blank, select one blank cell, and that's all. Click OK. Okay, so you will get this result. In the similar way, I want you to do the next to this adjacent to this table to sample assuming unequal variance. So I'll wait for a few minutes. Yes, I will repeat the step. We'll go to the data tab. In that data analysis, we have two options: t-test, two sample assuming equal variance, t-test, two sample assuming unequal variance. So which one to be selected? That is decided by the F test. And there is one more way, that is the smart way, that smarter way, or we can say the trick behind that of one to so to make you understand that too, we will first perform this t-test by taking both the cases, and I will show you what is that trick to identify which test is the correct one. And then let us verify with this F test whether we have the trick which we have taken is correct, or whether it is working. Okay, whether it is matching with our F test result. So
Ma'am,
when
what
you
is,
select two t-test, yes, yes.
ma'am,
So when you take, just let me complete. So when you take the two sample assuming equal variance, you have to input variable 1 and variable 2. So that is the sales and the IT score. Yeah. Yes, you can continue, ma'am. What is the query?
ma'am, what is alpha? What is, should be the value of alpha when the variance is unequal?
Variance unequal or equal anything, the alpha by default is 5%, ma'am. We take always
5%.
5%.
Okay, okay, ma'am. Okay.
Yes, yes. By default. Otherwise, if it is mentioned, we take 1% or 10%, whatever is mentioned. If not, by default, it's always standard value is 5%. So then after performing this with equal variance, next to that only please perform for unequal variance too, so that we can compare both the result and see what is the difference in the result, and which is to be taken forward for giving the conclusion. Okay, so let me also do the unequal one, and let us now verify it. So next one, unequal variance. Okay, so input ranges is same. variable 1 range, variable 2, hypothesized mean by default is 0, labels, alpha by default, output range, okay. So to decide which is the suitable one for this case, it will change for different data depending upon the variance test. Okay, depending upon the variance test, it changes. So let us see here which is the correct reliable one. So it is decided by the DF. It is decided by the DF. If you notice, all the summary would be same. Your T stats will be also same. Okay, because T stats is nothing but the calculated value that will not change whatever you take, because the formula is going to remain same. But because of this DF, your probability value, which is I'm going to highlight with green color. If you notice in both the place, the difference will be in the P value, probability value. I think you can observe that. Rest all value will be same except the probability value, because that probability value is computed with the help of T stats and DF. Okay, so hence that value is differing because the DF is not same. So which is the correct DF for this sum? That particular type of t-test should be considered for making this conclusion, and that we will verify it with the f-test also. So in general, the DF is computed as, okay, in general always DF, the degrees of freedom is computed as, DF means degrees of freedom. It is total number of observation, generally denoted by n minus 1. I'm repeating, total number of observation minus 1 for one sample. For one sample. So here we are having two samples. So for the first sample, it is 20 minus 1 is 19. Then again for the second sample, it is 20 minus 1, 19. So total it is going to be how much? 38. So the result which is showing DFS 38 is the correct one. Correct one means the suitable one for this. So that is the first one. T-test using assuming equal variance. That as DFS 38. Now let us verify that this by f-test, because it is to check whether equal variance and variance is unequal to be verified, which is done by f-test. So let us go for f-test. So that again is available in data tab, data analysis, f-test. See, that itself it is mentioned. F-test, two samples for variance. That is to check the variance. So variable 1, just select the variable 1 range. Then variable 2 range. then label alpha by default, and output range, of course, let us take a little far down, and okay. So before this, let us write the hypothesis for this. So here also you can notice the DF. 20 minus 1 is 19. 20 minus 1 is 19. So what is the hypothesis? So standard hypothesis for null hypothesis, we say that it is equal, right? The notation is equal. So variance 1, that is variance of sample 1 is equal to variance of sample 2. And alternative hypothesis is what? Variance of 1 is not equal to variance of sample 2. Okay. Fine. So of course we decided by the p-value. This is our p-value. Decision rule will remain same for all the hypothesis. Just for your reference, I am showing that slide once again. P-value less than 0.05, we reject the null hypothesis, right? P-value less than 0.05, we reject the null hypothesis. Coming back to our Excel sheet. So your p-value is greater than 0.05. So what we can say? We do not reject the null hypothesis. So what is the meaning? We accept the null hypothesis, that is variance 1, variance of sample 1 is equal to variance, that is we do for that population, sorry. So hypothesis testing for population. So variance for that population 1 is equal to variance of the population 2. So that is what we got here also. T-test assuming equal variance. So this is how you can relate that whether you have choose the correct t-test. Okay, this is how you can verify it statistically. This DF is to the trick what I said, but statistically to make it reliable, this is how the step goes. So we do the hypothesis testing for population with the help of sample. So our population variance, this variance will not match. Okay, please don't get confused with this because this is sample variance. What we are computing is sample, but testing is done for population. We go with the result for population. So if our population variance is equal, then we go for t-test assuming equal variance. If our population variance comes to be not equal, then we assume unequal variance. So that is what this F test is for. Okay. So finally, of course, we have to go for two tail. So this is what we have to use. I will highlight it with a different color. Yeah, this is looking, yeah, better. So this value I have to compare with 0.05. Yes, it is less than 0.05. So we reject the null hypothesis. So we reject the null hypothesis means what is the conclusion we can say? There is a significant difference in the productivity between sales and IT. Okay. So in the similar way, just for a practice, I would suggest you all to do for one more case, sales with HR or HR and IT with HR. So this is how the step goes. And you can give the conclusion accordingly. So you can perform so that if you're having any doubt, you can clarify it. So once you perform, then you may come with some certain doubts. So you can clarify it. Now, if this one test is done and if you are able to understand, then the other test will not take much time. Okay, here I made it to make you understand very detailed. So I had gone very slowly, step by step. Then further analysis, just by performing and directly by p-value, you can give a conclusion. Only this particular test will take little time to understand the first one you're doing. And that too, here we have to do two tests. That is, first you have to go for a F test to decide which T is to be taken. So here itself, two exercises has been done at one time. So there are a few questions. Let me take. Ma'am, please, ma'am, means we have calculated the F test for population and T for sample. Testing is done for population with the help of sample. This is the one statement which has to be remembered. Hypothesis testing is done for population with the help of sample. So when I say here in F test, I am comparing the variance. It is sigma 1 equal to sigma 2. That is sigma 1 square is equal to sigma 2 square. That is what sample, that is population. When it is sigma 1 square, that is sigma means population notation. Okay. Again, when you go for t-test, we write mu1 equal to mu2, the statistical notation. So mu stands for population notation. But to generalize the result for population, we test the sample. So either it is t-test, yeah, z-test, yeah, f-test, whatever test, you are doing the testing for population with the help of sample data. Okay. What is the difference between one tail and two tail? Yeah. See the alternative test. Alternative is the alternative sign for null. In null, we always take the standard claim is equal. So alternative, it is not equal. Now, what do you mean by not equal? It can be either less than or it can be greater than, isn't it? The variance is less than, yeah, greater than if I'm saying not equal. So here I am not specifically focusing on one side. In general, we are just saying whether there is significant difference, yeah, not difference. We are not focusing whether there is less significant or more, or which is better or which is weak. No, we are just seeing whether there is significant difference, that is yes or no. So equal, yeah, not equal. Hence, it is two tail. If you are specifically mentioned somewhere, check the average height of the student is less than 150 centimeter. So if you are going to see typically towards one side less than, then it is one tail. Or specifically towards greater than, then it is going to be again one tail. But just you want to know whether they are equal or not equal, then it is two tail. Yes, if we first check F test for to select which T test to be taken, then mainly which value we need to check? The P value, because they are given sample value which is not same. P value only you have to take and decide whether variance is equal or not. If the result come to be variance is not equal, then you will take T test of assuming unequal variance and you will perform. And of course, you can match the DF. That DF concept will hold true. Could you measure two dependent and two independent variables at a time? For example, could you compare the awareness of adoption of Ayush system between urban and rural communities? Of course, this is rural and urban are going to be independent, right? So awareness and adoption you mean? No, that you have to do separately only. First you will do awareness separately and adoption separately for urban and rural. Or if there is any common relation factor which you can make it club it together, then you can do. Otherwise, you can't take that awareness and adoption value together. That is two different thing, right? So awareness separately you have to do take and check what is the result, and adoption separately to know what is the result. So that you can let see that what is the difference in awareness and adopting that. So in that case, there are two different factors, and that would be a different, not coming, not under T test. When if you want to take two factors, so it will go under the multiple factors under ANOVA. What we say, different factor levels. For T test, only one level only between the sample, whether it is if it is independent or dependent. If it is dependent, the procedure is same, but the only thing is we select pair T test. Okay, so I will show that also. Let us conclude this. I'll wait for 2-3 minutes more. Then I'll just perform and show you about the pair test too, so that any query in that we can discuss. So let us take the third question over here. As employee productivity improved after training. So that means here we are having a data of productivity before training and a productivity after training. So this is what that information is. So let me take this to a new sheet. So again here we have to segregate it into two different things, before and after separately. So it is about the employee productivity before and after training, right? So it is a dependent data before, after. So let me remove this. So when it is like this, before, after, or a one particular information case having two data at different point, different time point, different areas, then we go for parity test. So procedure now will same: data, data analysis, t-test pat to sample for means. Okay. Variable 1 range, variable 2 range, mean difference by default 0, label, output range, any one cell, and okay. So performance, that is performance, I mean inputting and getting outputting, that procedure is going to remain same everywhere. You have to input whatever is asked and you select whatever is required and just okay. Then you get the result. That is how it happens in all the thing. So one test you are thorough, uh, like out, it goes for the remaining all test. So okay, and you get the result. Now you would be much more a bit easy for you to give the conclusion. Of course, we have to take for two tail. So this value, so this value is approximately 0, isn't it? Because it is 1.06 to e raised minus 0.6. That means 0.50106. And which you will compare with 0.05. So here it is less than 0.05. So we reject the null hypothesis. Okay. So now reject the null hypothesis means We reject there is no significant difference statement. So what is the conclusion? There is significant difference in the productivity after training. There is significant difference in the productivity because we have to reject. So yes, employee productivity is improved after training. That is what the conclusion we are getting from so I hope this was clear to you all about the t-test, how to perform, how to understand which one to take. And can you notice the DF over here? It is 14. Why it is 14? It is not two different sample. It is dependent. Okay, it is dependent. So this are the 15 employee data, and that 15 employee only after data. So it is only 15 samples here. That is 15 observation, 15 participant or 15 employee. Hence it is 15 minus 1 is 14 here. Okay, so don't get confused that 15 minus 1 and 15 minus 1, 14 plus 14, 28. No, here it is not independent, here it is dependent. So this information is of before and after of the same 15 employee. Hence it is 15 minus 1, 14. And p-value is less than 0.05, we reject the null hypothesis and we conclude there is significant difference in the productivity after training. That means what the claim statement says. As employee productivity improved after training, yes, the claim which is stated is can be considered as evidence to give this statement that employee productivity improvement as improved after training. So hope this t-test was clear to you all. In case in future, if you are having the information about variance known, then you will go for the last test, that is Z test. For means, procedure will remain same. If you see here, variable 1 range, variable 2 range, and since variance is known, see here it's also mentioned in the input place itself. Variable 1 variance, and in bracket it is mentioned, see, known. If it is known, then only we can type it. But here, of course, it's not known to us. So hence we cannot go for Z test. I'm repeating again, the variance which we are getting is for sample, and the variance which they are asking here to input is for population, which is unknown. Okay, hence we don't go for this. But in future, anytime if you are having the variance value known, then you can go for this Z test. Okay, but if it is paired dependent, you have to go for t-test for dependent. That is for paired t-test, right? So I can give you another 5 minutes for any discussion related, any queries related what we have discussed in today's session. I can take the questions, any doubt to be clarified. And of course, practicing. Please practice with other samples as I have done with sales IT. You can do with other combination so that if any doubt comes, you can ask me in tomorrow's session also in the beginning. Maybe not now. If while performing with me, it might be comfortable or easy also. Okay, but when you're going to do actually alone, maybe you can come across few questions. So you can note it down and you can ask me in tomorrow's session. Currently, if you're having anything, you can do ask me. And that's all from my side today. Thank you so much once again to all your active participation, Yes, even boost me to make the each day successfully completing. And thank you so much. So, sir, that's all from my side. If there is any question, we can give the time to the participant.
Yes. So thank you so much, ma'am. Dear participants, if there is any questions you can ask, otherwise we can leave the session for today.
Thank you very much, madam. This is very useful to the research scholars who has the statistical department.
Yeah, thank you so much, sir.
So
Thank you so
you are
much.
explaining very well, madam. I felt very happy to share with my feelings. I am from Dr. M. Srinivas from Dean Puttiramlu Telugu University, Andhra Pradesh. Thank you, one
Oh,
and all.
thank you so much, sir, for your
Thank you, madam.
encouraging
Good
word.
night, all of you.
Yes. So thank you so much, dear participants. Successfully we completed day 3 and we will meet you more tomorrow by 6 o'clock. Thank you.
Yeah, thank you, everyone. Bye bye.